Hi, welcome back. This is our session on cloud native methodology. So we're going to have a look at what's really powering this move in popularity of cloud native development practices, and have a look at kind of some of the technology that's underpinning that movement. So first off, I want to mention the phrase digital transformation, and that's top of mind for a lot of organizations today. Whether businesses are trying to modernize existing applications or creating net new applications, they're really focused on creating custom applications that allow them to get as close as possible to the customer. So this helps them really do a couple of things. One of those things is drive brand awareness and identity awareness by being more present in more locations, through more devices and more settings for their customers. It also allows them to generate revenue in ways that maybe they previously weren't exposed to. So mobile applications, IoT is big, telepresence for education institutions as well as enterprises. And finally, increasing and expanding on the user experience for their end users and their internal and external customers that are interacting with their workloads. The closer they get to their customer, the better experience their customers are having. This helps, again, grow the revenue as well as their identity and their brand. So digital transformation is really top of mind for a lot of organizations today. And building on that, whether they like it or not, all kind of businesses and organizations today are IT companies as they look to create applications and ways to get closer to their customers. So what powers this ability or this drive to create applications? What allows these businesses to create applications? And really it's focused on two things. One of those things is being able to create or build software that fits the needs of their business and their customers' needs. So we estimate that as of today, 75% of applications are going to be built, not bought. So the ability to build and customize these applications is going to be very important for our customers. It's going to allow them to innovate and disrupt their industries and to reach customers in ways that they haven't been able to before. So what is really powering this change in application development, and what is kind of underpinning this new development methodology? And really we want to look at containers as an enabler for this digital transformation. And so why containers? Well, they do a couple of things really, really well. They allow developers and infrastructure users to create and boot these environments very quickly. So they're very, very fast. They come online very fast, and they allow our developers to test, create, and deploy applications a lot quicker than they could with maybe traditional virtual machines. Also, they're lightweight, so they require very minimal resources, especially when compared to their predecessors in virtual machines. And finally, since a container contains everything it needs to run an application, it's portable. So we can ensure a high probability that applications are going to run the same as they do on my developer's personal workstation as they do when we deploy it in VMware Cloud, for example. So we can build and test these things locally and push them to our production environment with a very high degree of certainty that these things are going to run. So we've talked about containers as an enabler for this digital transformation, but what exactly is a container? So first you start off with maybe a developer's workstation, a laptop, just like we have here, or even a virtual machine or a server running in VMware Cloud. We start with a host operating system, usually a Linux operating system, but we need some sort of operating system as the container host or the base of the solution here. Next, we have a container engine. This is essentially the software that runs on the host operating system that's responsible for powering the container, building the container, pulling the container down from a remote location, running and monitoring the container. So after that, we have actually the container engine pulls the container down from a remote location, or it's built locally, and it contains essentially the user space required to power the application. So it's an isolated instance of an application that has binaries and libraries that are required by the application, but all of that is contained within the container. So essentially, if we have 10 containers running on a container host, then we have 10 isolated instances of a user space. So this allows us to separate and segregate our resources on a single host operating system where we previously needed multiple virtual machines or even multiple servers to accomplish that. So containers help us do for application development today what virtual machines allowed us to do maybe 5 to 10 years ago for allowing us to run more applications with less resources. So we're always trying to get more from less hardware, and containers is the next kind of logical iteration of that journey. But containers are not new. They've been around for a long time. We had jails with FreeBSD in the early 2000s, Solaris zones in 2004, and then the first real implementation of Linux containers with LXC in 2008 using C groups and Linux namespaces. But there was a huge explosion in 2013 of container usage, and that was largely powered by the introduction of Docker Container Engine. Now, Docker didn't invent Linux containers, but what they did was do a great job of making it easy to interact and manage and run Linux containers. So Docker made it simple. So Docker gave us an API and a CLI tool that allowed us to take a Docker file that defined kind of the contents of an image that we wanted to create, use the Docker CLI tool to build that image. We also could use the same CLI tool to run that image that we built, to create a container from the image that we built. And then finally, we use that same CLI tool to push our image to a remote registry. So other developers within our organization or developers all over the world could pull that same image down to their local workstation or their local server and run that application or that set of applications the same as I did previously when I built the container. So we talk about images versus a container. What is an image? What is a container? An image is essentially a layer of read-only file systems that comprise an application or perform a certain task. So if we look at our example, we have our boot and root file system that sit at the bottom, and then our Docker file has told us to utilize libraries from Ubuntu and then pull in the Apache program and then run a set of commands on launch to configure and run the Apache service in this image that is called my web server. So this is just a simple web server image. So that image is read-only, it's static, nothing kind of changes about that image until we use the Docker command to run that image. So once we run the web server image, we have created a container. And this essentially creates a thin, another read-write layer on top of the existing read-only layer. So as the user, we make changes to that read-write layer, and we can run our application, we can create new websites on top of our root website, et cetera, et cetera. Now, if we want to make changes to that image, all we do is create a new image based off our container. So this allows us to continually build on top of a kind of a base container while not having to go in and troubleshoot or take apart code like we would maybe in an older monolithic application. So we have our container. Now we've made our changes. What if we want to share those changes in a new image? Well, we need to push that container to a container registry. So in our example on the screen, I've referenced Harbor, which is an open source enterprise container registry sponsored by the VMware community. So we can push our image after we've made our changes and committed our changes and created our new image to our Harbor registry. And then all of our developers within our organization can grab that image from the Harbor registry down to their local workstations or onto their servers to run that application as they would previously. Now, Harbor is what we call a private registry. This is something that we as an enterprise manage and control on-prem. But there's also public registries out there. The most prominent of those is Docker Hub. This is the default registry for the Docker daemon. So if you do a Docker pull without configuring a private registry in Docker, it pulls from the public registry. Now, The public registry, especially Docker Hub, is great. It's hosted and managed by Docker, so you don't have to worry about managing container registry. It's pretty simple and straightforward. You can do push and pull commands without having to do much kind of education or awareness of what a registry is or how it works. On the other hand, anyone can host an image there. So there are security concerns about vulnerabilities being exposed if I pull a vulnerable container, a container that contains a vulnerability into my environment. Or there could be more malicious things like malicious code injected into containers that could cause problems if pulled down into an environment. So there's a lack of control over the images that are running in public registries. So enterprises are usually focused on how do we get that control and enterprise functionality and security functionality in a container registry. And that's where something like Harbor as a private registry comes into play. So with Harbor, obviously you as the infrastructure manager or the end user are responsible for deploying the registry and managing the registry. But you also have full control over the lifecycle of the containers, who accesses the containers, and then the rules and governance over who can pull and when a container can be pulled. So for instance, with Harbor, if I push a container to Harbor, I can set up to automatically scan that container for vulnerabilities. And then if another user wants to pull that container or that image, if the image contains vulnerabilities, then Harbor prevents that image from being pulled down into the environment. So this way, we have that enterprise functionality of security specs to say, if any image has a vulnerability, do not let that run in our production environment. So these are some of the features and functionality that come alongside with a private registry as opposed to the public registry. So we talked a little bit about containers, but we can't just take our traditional monolithic applications or even net new applications, drop them in container and call it cloud native. There's a lot more that goes on. So I've said monolithic a couple of times. These monolithic applications are usually single large code bases. If we want to scale the application, we have to simply add more resources. We can only really scale it vertically. It's slower to update. If there's a failure, there's usually a single point of failure. If the app fails, then we're in trouble. What we're really after is taking an existing app or developing net new applications in a microservices type of methodology. And what this means is we have an application that's comprised of multiple services that do one job, and they do one job really well. And so this allows us to scale things independently, even create and develop these pieces independently so our developers can focus on one task at a time. They can work separately but in parallel, and we use some sort of orchestration unit, usually based on APIs, to connect all these pieces together. But as you can see, there's a lot on the diagram on the right that kind of goes into connecting all these pieces together, and how do we ensure that they can communicate with each other? How do we monitor them to ensure if there's a failure, we have some remediation? How do we scale these things independently? And that's where we want to talk about the fact that a modern application architecture requires a container platform or an orchestration system. So that concludes our lesson on cloud native methodology and an overview of container technology. Join us in our next session where we'll go through Kubernetes as our container orchestration system and our platform for modern applications.